Hi, hello everybody. Today we're looking at 7.6, factoring polynomials using the greatest common factor, or the GCF. So the first thing that we're going to go into is what is greatest common factor, what is GCF, and writing a polynomial as a product of factors is what we're calling this thing called factoring. I'm going to zoom in a little bit here. Okay. So the GCF, or the greatest common factor, is literally it's defined as the greatest factor in common between two numbers, or two monomials. So what we're doing here is, that idea that we were doing in the last section with solving an equation that's in factored form. We want to be able to do that, but we don't always have to depend on is something in factored form in order for me to solve it. And things aren't always going to be in factored form for you to solve it. That's just not the way the world works. So we're going to have to be able to take equations and put them into factored form in order to solve them. And one of the easiest ways, and one of the first ways we should always check for is, can I factor it by just taking a greatest common factor? And let's see how that works. This right here is a polynomial made up of two monomials, and each monomial has different factors. 2x squared is made up of 2 times x times x, right? This would be kind of like the simplest way that I could write it if I expanded it all out. Now, 18, if I want to go for the simplest numbers that make up the number 18, I'm going to be looking at 2 times 3 times 3. Now, what do all these things have in common? They're all prime numbers, which means none of these numbers can be factored down anymore. So that's how I know that this is the simplest form of writing 18. So these are all the factors of 18. These are all the factors of 2x squared. What are my common factors? And better yet, what are the greatest common factors? Well, I can see that they both share a 2. Other than that, I don't see anything else. So it looks like the greatest common factor, the GCF between these numbers, between these monomials, is 2. So I'm going to put that right here. Now, what happens when I actually, I'm going to use the word undistribute. We're basically using the distributive property in reverse. If I were to take this 2 out of each of these terms, and I was to divide it out of each term, when I divide 2x squared by 2, I'm left with just an x squared. And when I divide 18 by 2, I'm left with 9. Now, I wonder if everyone could follow along with that, because basically if I go back and I undo what I just did, I would multiply. Multiply 2 times 2x would get me 2x squared. And multiply 2 by 9 would get me 18. So I'd get right back to where I started just by undoing the operation I just did by undistributing. I would redistribute. Okay? So what I've done here is I've put this into factored form simply by taking out what the two numbers had in common, which was a factor of 2. So let's try and do that again with this next example. And I'm going to take a look at 15y cubed. 15y cubed has factors, 15 has factors 3 and 5, so 3 times 5, and then it's going to be times y, times y, times y. Now let's look at the next one, 10y squared. Well, 10y squared is going to be 10 is 2 times 5, and then times y times y. So what do they all have in common? Well, I'm seeing 5's, and I'm also seeing y's. I'm seeing 2 sets of y's. So what do they all have in common? It looks like 5y squared can be divided out of each of these terms evenly. So let's put that aside, 5y squared. And let's see what happens. When I divide this out of 15y cubed, I'm left with 3y to the first And then when I divide it out of 10y squared, I'm left with 2 and no y's actually. Just a 2. So I can close up that parenthesis there. And that would be my factored form. Now let's go down to example 2 and solving an equation by factoring. So not only am I going to be factoring this, but now I'm also going to use what I learned in the previous section of the zero product property, and I'm going to be factoring and then solving. So to solve an equation using zero product property, you may need to first collect the terms on blank side of the equation and then factor. So I want to collect them on the same side. So just like I would try and collect all of the variables on the same side when I was solving like a regular algebraic expression, I want to do the same thing with this. So if I want things on the same side, I'm going to say 4g squared, and I'm going to add 6g to both sides. And that's going to bring plus 6g to the left and leave just a 0 on the right. Now I'm going to come over here and I'm going to say I want to collect all my terms. So I'm going to say 18y is going to stay there, and I'm going to subtract 6y squared from both sides. I'm going to put the minus 6y squared over here equals 0. And why did I put it on the left side of the 18? Because I wanted it in descending order. I wanted it in so that the largest exponents are first, and I'm just trying to do that to save time. So now what I'd like is for all of you to try and factor this before I do. Alright, so take a second, pause, and try and factor these two things. Look for the greatest common factor between them, factor them down, and then stop. And I'll help you solve the equation after. Alright, so hopefully at this point you were able to factor this down. This one right here should have a common factor of 2g, and then on the inside 2g plus 3, and it should say equals 0. And this one over here should have a common factor of 6y, and on the inside we should just have negative y and plus 3 equals 0. And now what we want to do is use the zero product property to solve. So think back to the previous section. Use the zero product property to solve these equations. Well, what does the zero product property say? It says either this or this has to be equal 0 if they're multiplying each other and their product is 0. So again, with part B, either this or this has to be 0, or in order for their product to be 0. So one of these two things, one of these two things. We need to separate and solve. Do that on your own, and I will check your answers when we get into class. Good luck. Now the last thing we want to do, again, just like always, is a real-life application. And basically we have this female athlete testing her vertical jump. And I can model her vertical jump given by this equation right here. So basically, when I graph this equation, it's going to be, that type of shape. And I want to know how many seconds is she in the air. So I want to know, basically, start, go in the air, and then come back down and hit the ground. And the hint here is that when she hits the ground, y equals 0. So that's important. It basically is telling me find the solutions to the equation when y equals 0. So it gives me the equation, and it gives me what I want to find. Y equals negative 16t squared plus 12t, and I want where y equals 0, so it's going to say 0 equals negative 16t squared plus 12t. Alright, now we know what we have to do. we need to find a greatest common factor, we need to factor it, and we need to be able to solve it using the zero product property. I'm going to leave it up to you. Find the greatest common factor between these two terms, factor it out, and then solve. Alright, I will be looking at this one especially when we get into class, and we will go over that if we have any major issues. Good luck, everyone.